Look around you. Everything you own, from the smartphone in your hand to the car in your driveway, was built by human labor combined with highly specialized, single-purpose machinery. But that industrial paradigm is officially dead. We are currently witnessing the most aggressive hardware pivot in modern manufacturing history. Bipedal humanoid robots are no longer clunky science fair projects confined to university research labs. They are walking factory floors right now, and they are ready to learn. And in traditional manufacturing faces a severe and structural global labor shortage. In the United States alone, the National Association of Manufacturers projects that over 2 million manufacturing jobs will go completely unfilled by the end of this decade. The demographic math simply does not work anymore. Production lines need flexibility, endurance, and rapid intelligence. Heavy single-purpose robotic arms bolted to a concrete floor cannot adapt to dynamic warehouse environments. They cost millions of dollars and months of downtime to reprogram whenever a product line changes. Enter the purpose humanoid. Hardware companies like Figure AI, Aptronic, Tesla, and Boston Dynamics are no longer building robots for specific isolated tasks. They are building biological hardware equivalents. They are deploying machines equipped with tactile finger dexterity, bipedal navigation, and profound spatial awareness. The mission objective is simple but revolutionary. Drop a humanoid into an environment built strictly for humans, give it a high-level verbal task, and let the onboard neural network figure out the physical execution. The era of hard-coded, rigid robotics is over. We have entered the age of autonomous, self-learning silicon labor. How did it get hit so fast? 5 years ago, cutting-edge robots struggled to open a standard door without destroying their own hydraulic. Today, they are seamlessly making precision coffee, carrying heavy engine blocks, and assembling complex automotive parts. Secret sauce is not just better titanium joints or stronger electric actuators. The real breakthrough is pure software friction removal. The industry completely abandoned deterministic programming. We stopped writing millions of lines of brittle if-then code for every single possible mechanical contingency. Instead, deep tech engineers fully embraced end-to-end neural network and look directly at the Figure 01 robot platform. This machine operates completely differently from legacy Boston Dynamics hydraulic systems. It processes raw pixel data through onboard optical cameras. It feeds that visual stream directly into a massive vision language model trained closely with OpenAI. The neural network processes the semantic goal, calculates the necessary physics, and directly outputs motor joint torque commands in real time. It learns new physical tasks purely by human demonstration through teleoperation data collection. A human engineer puts on a VR headset and haptic tracking gloves, completes a factory task a few hundred times, and the neural network builds a robust imitation learning model. This is exactly how biological humans acquire muscle memory. Tesla is currently applying the exact same Dojo supercomputer architecture used for autonomous vehicle, full self-driving, directly into the brain of the Optimus robot. Neural net automatically generalizes complex tasks. If you teach the network to fold a black shirt, it organically understands how to fold a blue shirt without requiring a new software patch. This cognitive software leap changes the entire robotics industry. Code is no longer the engineering bottleneck. The only bottleneck is how fast we can stamp out the physical metal chassis on the assembly conveyor. If you think this is a futuristic concept that is still 5 years out, you are not paying attention to the real-world operational data. The multi-billion-dollar deployment phase is actively happening right now. MW Manufacturing is officially deploying Figure 01 humanoid robots to its massive Spartanburg plant in South Carolina. The robots are actively taking over heavy sheet metal handling, dangerous body shop work, and highly repetitive warehouse logistics. Amazon Robotics testing facilities are currently running agility robotics, digit humanoids, directly alongside organic human floor workers. Mercedes-Benz just inked an aggressive expansion deal with Aptronic to put the Apollo bipedal robot onto active automotive assembly lines. These are absolutely not shiny pilot programs meant to generate corporate press releases. These are strategic, multi-million-dollar capital expenditures aimed entirely at completely restructuring the fragile global supply chain. And for the average global consumer, this massive technological shift brings a massive economic shockwave. And a major manufacturer can autonomously scale production without worrying about human fatigue, worker compensation claims, or complex shift scheduling. The fundamental cost of raw physical labor rapidly approaches zero. A humanoid robot relentlessly working 24 hours a day, 7 days a week, fundamentally crashes the baseline cost of creating physical goods. This deflationary curve directly impacts the sticker price of the car you drive, the house you live in, and the premium electronics you buy. It also creates a massive and immediate transition problem for the human workforce. General-purpose robots are coming directly for middle-skill manual labor jobs at an unprecedented velocity. We are standing at the absolute jagged edge of a physical labor disruption event that rivals the invention of the combustion engine and the industrial assembly line. Current overarching challenge in the robotics industry is no longer about proving that the neural software works. The software absolutely works. The primary remaining hurdle is pure, hard manufacturing scale. Realistically replace millions of missing human workers. These robotics companies must urgently transition from building artisanal, handcrafted prototypes to mass manufacturing millions of autonomous robotic chassis. This is exactly where technology companies with massive vertical integration have a distinct operational advantage. This is the precise reason why Tesla is aggressively pushing the Optimus humanoid program forward. They already successfully mass-produce millions of electric vehicles packed with advanced battery density packs, sophisticated high-torque electric actuators, and localized computer vision processing chips. An Optimus robot is essentially a Tesla Model Y, aggressively compressed into a bipedal biological human form factor. Heavy industry analysts project the hardware cost of a humanoid robot will aggressively crash below $20,000 within the next 5 years. Let that stunning unit economics reality sink into your brain. You will soon be able to purchase a multi-purpose physical laborer for the exact same retail price as a cheap budget economy car. The financial return on investment for a factory owner or logistics manager becomes mathematically undeniable. Once the initial hardware capital expenditure is fully paid off, the strict marginal cost of that automated labor is just the raw electricity required to charge the lithium-ion battery. We are rapidly entering a hyper-competitive space race between the absolute biggest tech conglomerates on Earth. OpenAI, NVIDIA, Tesla, and Microsoft are collectively pouring billions of venture capital dollars into foundational humanoid embodiment models. Whoever successfully wins this hardware race controls the ultimate universal intelligence machine. It will directly control the new foundational standard of physical labor for the entire planet. The historical era of pure human supremacy in hard manual labor is coming to a rapid, undeniable, and permanent close. The autonomous hardware revolution is absolutely not a distant sci-fi movie prophecy. It is actively happening on the heavy assembly line floor of a BMW factory right now. Within a single fundamental human generation, we will witness the greatest decoupling of macroeconomic productivity from biological human labor in the entire history of our species. The baseline cost of physical manufacturing will absolutely plummet. But humanity must drastically and urgently rethink how we distribute global wealth and personal purpose in a society where physical work is completely automated by deep learning neural algorithms and titanium chassis frames. Are our governments prepared for the rapid economic fallout? Are you personally prepared for the massive tectonic shift in how the global economy physically operates? And you need to pay aggressive, laser-focused attention to these massive technological industry shifts because they will directly alter the trajectory of your entire career and your daily biological life. If you found this operational business intel highly valuable and want to stay completely on the bleeding jagged edge of the AI hardware revolution, hit that subscribe button right now to officially join NeonSync AI. We relentlessly process the overwhelming daily tech noise to bring you the highest quality data signal on the market. Turn on your channel push notifications immediately so you do not miss our next rapid-fire, deep breakdown on the rapidly evolving future of generative machine intelligence. The digital future is being violently ripped out of the cloud and directly into the physical world, and we are going to meticulously document every single massive step of this historical transition. What is your completely honest take on humanoid robots actively taking over the global supply chain? Drop your raw, unfiltered thoughts in the comments section below right now, and let's get a heavy intellectual debate started. Stay incredibly sharp, adapt fast to the new reality, and we will see you back on the front line in the next video.